Well, hello. Thanks for tuning in once again. Today we are actually going to rewrite mixed numbers into improper fractions and improper fractions into mixed numbers. I know the teaser yesterday was we were going to add and subtract them, but I'm going to save, or yesterday, last time, but I'm going to save that for the next lesson. So today we're just going to convert. No actual adding or subtracting going on yet, just yet. Okay, so what is a mixed number? We need to know that before we can really be able to use it, right? Well, a mixed number is just a number and a fraction. Simple as that, right? There you go, 5.5. 5 is our whole number. Fraction is the half. So what is the improper fraction and why do we say that it's improper? That makes it sound like it's bad. Um, it's just as simply as a fraction where the numerator, or that top number, is bigger than the denominator, or that bottom number. And I'll just let you know, math teachers, when you get a final answer, we don't usually like it to stay in an improper fraction, but we will usually tell you when we want it to be simplified into a mixed number. So actually, as we prepare for someday doing some algebra, we use improper fractions all the time, and we pretty much leave them there too. So don't worry about it unless I tell you you have to convert it. So let's get started with, first of all, rewriting a mixed number as an improper fraction. I'm going to try and do this a little bit visually for you because I know so many of you think with your eyes in your head, right? The eyes in your head. So we'll see if I can do that a little bit. So my first problem I'm going to do for you is 3 4/5. I'm going to write that as an improper fraction. So we can think of 3 4/5 as 3 plus 4/5, the whole number plus the fraction. And the 3, we can break it out. It's 1 plus 1 plus 1 plus 4/5, like that. Okay, so visually, here's what we're talking about. We've got a whole plus another whole plus another whole plus the 4/5. Okay, and each of these wholes, we can rewrite them as a fraction of their own, 5/5, because that's 1, right? That is 1 right here. 5/5, 5/5, adding those up and adding the fractional part, right? Now, yesterday we learned, last class, lesson, we learned about adding fractions. So this is starting to look a little familiar. So here we go. Notice I've combined all of the denominators into one because they were all the same, right? Let me go back. See how they were all the same, all the denominators? Because 5/5 is one whole. We can just add up the numerators. And as you can see, I could just sit here and count each of these. 5 plus 5 plus 5, there's 15, and 4 more is 19. So there's our answer. But that's great to understand the concept. But what if we want you to just be able to do this? So I made up this little graphic for you to give you another visual and some instructions. So to do this without having to rewrite it like this the long way, I've given you these 3 little steps. It's pretty simple. First, we're going to multiply the denominator by the whole number. So the first thing we're going to do is, it's kind of like the multiplying up. Whoops. There we go. Kind of like multiplying up. We're going to multiply this number by this number. And then I'm going to write it right here, my result. So 5 times 3 is 15. Okay? 5 times 3 is 15. And then I take the 15 and I add it to the 4. So 15 plus 4. So see how it says take that product. You guys know what a product is. I know I'm talking in high mathy terms, but you know, we can do this, people. 15 plus 4 is 19. And I had to do this up here because of my picture down below. And then just copy the denominator. So instead of having to write all of this out like this to figure it out, we can simply do this. And a lot of this you can do in your head. 5 times 3, you can do 15. 15 plus 4, and then write your answer for your numerator and copy your denominator. That's our 3 steps. So let's see that again. Here we go. Same step. 3 times 10. Okay, that's our first step. Multiply the denominator by the whole number. 3 times 10 is 30. Write that here. 30 plus 2, that's step 2 here, is take the product and add on the numerator. 30 plus 2 gives us 32. And the denominator stays the same, so I should really say there, copy the denominator. And there we go. It's that simple. All right. Your turn. See what you can do with this one. Okay. You're so smart, you can do this one too. One more. You do this one. Okay, now you're an expert at converting mixed numbers into improper fractions. Now we need to go the other way around, and you can become an expert at that. Now, we're doing the opposite of what we just did. Remember, we multiplied first, and then we added. Well, watch. First, I'm going to show you again in more of a visual way, and then I want to show you how to do it the shortcut. All right, so 10 thirds. So remember, 3 over 3 is 1 whole because we've got it broken up into thirds. So let's see how many wholes we can get out of 10 thirds. So if we start adding 3's, 3 plus 3 plus 3, that gives us 9. And there's 1 left over. So this is our adds up to 10. Okay, we can rewrite it. I'm going just backwards of what we did a few minutes ago. Okay, we can rewrite it as 3 over 3 plus 3 over 3 plus 3 over 3 and plus 1/3. Now, add up these ones because 3 over 3 is just a 1, right? This shows us a whole. These are all 3/3 wholes. Okay, this shows us all the ones. Just all we did was take out our little dividers. Okay, these are all 1. Add them up, gives us 3. And we've got our remainder 1/3. It's that simple. Now, let me show you, very easy, how to do this without having to do all this drawing. Okay, so we want to convert 10 thirds into a mixed number. So, last time, first thing we did was multiply, and then we added. We're going to do just the opposite. First, we're going to divide, then we're going to subtract. Because we're going the opposite thing, we're doing the opposite. All right, we want the opposite answer, we're going to do the opposite. So what I do is I get out my calculator if I don't know how to divide the numerator by the denominator, if it's a really big number, but come on, we can do this. 10 divided by 3, how many times does 3 go into 10? Well, I know, ignore this, pretend we didn't know already. Okay, so 3 plus 3 is 6, plus 3 is 9. So I'm counting on my fingers. Okay, count on your fingers, and I write down that number. So it was 3. So first thing I do is I did 10 divided by 3. Okay, only I don't want the whole fraction part. Okay, I only want the whole number in front of the decimal. So if you do this on your calculator, 10 divided by 3, you're going to get 3 point blah, 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 blah. Ignore the blah, 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 blah. Okay, just take that number in front of the decimal point. That's if you use a calculator. If you use your fingers like I just did, there they are. There's 3 of them. Now, what is 3 times 3? How far did I get when I counted? I got 3, 6, 9. So I take the 9 and I subtract it from the 10, the original numerator that I had there. So that leaves me with a 1. That is our new numerator. Okay, that is our new numerator. And we just copy our denominator again. Denominators are easy in this. We just copy them. There's no figuring out denominators. Okay, so let's do that again. This time I wrote out the step. Divide the denominator into the numerator. So how many times does 8 go into 17? Well, let me think. 8, and then I add 8, I get 16. Oh, I better stop there, huh? Because if I go to the next 8 more, that's 24. That's bigger than 17. So 8 plus 8 is 16. So how many fingers did I count on? Of course, I was using these little guys over here. 8 plus 8, 16. That's 2. Like I said, put it into your calculator, and you will get 2 point blah, 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 blah. Ignore the blah, 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 blah. We don't need that right now. So we just need the whole number. Now, what is 2 times 8? How high did I get in my counting? I went 8, 16. I got 16. So in my head, this is what I'm doing in my head over here. 17 minus 16 to get my remainder. Okay, I'm just trying to get my remainder here. What's left that wasn't part of the 8, 8 thing? 1. So we put a 1 in the numerator. That's our new numerator. And we copy the denominator. The easiest part, just copy it. Okay, let me show you another one. All right, so again, we got 7 is our denominator. So we're counting by 7s. 7, 14. If I go to 21, that's too much. Okay, so again, you can use your calculator. 17 divided by 7. If I go into 14, if I go to 14, that's good. So how many did I count? 7, 14. I only counted 2. Again, 2. Now, 7, 14. So it was 14 was my highest number. I could do 17 minus 14. What does that give me? Left over? 3. So 3 is my numerator. 7. Again, we just copy that. Okay, that just gets copied to become our denominator. All right, you want to see it again? Let's do another one. Okay, and after that, it'll be your turn, you know. All right, this one's a little bigger. 9 is our denominator. 45 is our numerator. So 45 ninths. How many times is 9 going to 45? Well, let me see. 9, 18, 27, 36, 45. Wait a minute. I got to my number. I don't have a fraction. I don't have any more left. It's just 5. That was simple. Put that in your calculator. You get the answer 5. That's it. That's not even a mixed number because we don't have a fraction. But that's okay. Sometimes that's what happens. Sometimes it's cool that way. All right, here's your turn. Change this to a mixed number for me. Hey, last one, you guys. Your turn one more time. Be careful. Pick the right answer. Don't misclick. All right, we did it. I want you to do some more practice. That's what it takes to learn this stuff. And, of course, finally, tomorrow we really, or not tomorrow. I keep saying that. Why do I say that? It might not be tomorrow, but next time we really will add and subtract mixed numbers. Thanks for watching.